If you are going to have a problem like this, the very first thing which you're supposed to do, you're supposed to organize your problem. I mean, in this case, we have to organize the numerator. So what I'm going to do, I have limit with x approaching 4, and I'm going to have x minus 4 minus sine x minus 4. What I'm going to do, I'm going to simply put x minus 4 inside of the parentheses over x minus 4. Next, I'm supposed to rewrite this as two separate fractions. I mean, the main fraction have limit x is approaching 4, and I'm going to have x minus 4 over x minus 4 minus sine of x minus 4 over x minus 4. Next, I'm supposed to apply the theorem for the difference of limits. What I mean by that? The limit of the difference is equal to the difference of limits. That's why I can rewrite this as limit with x approaching to 4, and I have x minus 4 over x minus 4 minus limit x minus 4, and I have sine x minus 4 over x minus 4. X minus 4 over x minus 4 is equal 1. So that's why I'm going to simply write that I have limit with x approaching to 4 of 1 minus limit with x approaching to 4, and I have sine x minus 4, and I have x minus 4. Limit of constant is equal constant. That's why I have 1 over here. Minus, and let's take a look what we have over here. We have limit with x approaching 4, and in the denominator I have x, which is going to approach 4, so that's why the denominator is going to approach 0, and the numerator has also x, which is approaching to 4. That's why the numerator is going to be also equal 0. The fundamental theorem for limits says that if x is approaching 0 and I have x in the denominator and x approaching 0 and I have sine x in the numerator, so the whole expression is approaching 1. That's why I have to use this fundamental theorem for limits and apply into my problem. That's why this part is going to be equal 1. That's why 1 minus 1 is equal 0. This is the solution to my problem. We have another example on the board. Please notice that in the denominator we have sine, and we have x, which is going to approach 1. So the denominator is going to approach 0. If you are going to look at the numerator, I have x squared minus 1. So if x is approaching 1, 1 minus 1 is going to give me also 0. 0 divided by 0, we do not want to have that situation. So what we are going to do first, we are going to expand the numerator. We are going to use the formula for the difference of the squares. Do you remember the formula? Formula says a squared minus b squared is equal a minus b and times a plus b. So I'm going to rewrite this expression as limit with x approaching 1, and in the numerator I'm going to apply this formula, and I'm going to have x minus 1, x plus 1. In the denominator I'm going to have sine x minus 1. So what I'm going to do next, I'm going to rewrite the whole expression one more time, but this time I'm going to apply the theory for the limit of products, because you can rewrite this as limit x approaching to 1, and I'm going to have x minus 1 over sine x minus 1 times x plus 1 over 1, which is simply x plus 1. We said we are going to use the product of the limits. So I'm going to have limit with x approaching to 1, and I have x minus 1 over sine x minus 1 times limit with x approaching to 1, x plus 1. Now, what I'm going to do over here, I'm going to apply the property of exponents, and I'm going to just find the reciprocal of this fraction. I'm going to have limit with x approaching to 1, and I'm going to have sine x minus 1 over x minus 1 to power negative 1. And I'm going to copy everything wherever I didn't use, times limit with x approaching 1, and I have x plus 1. Now I can use the theories of limits, and I can rewrite this part of my problem as, open parenthesis, limit x is approaching 1, and I have sine x minus 1 over x minus 1 to power negative 1 times limit x is approaching 1, and I have x plus 1. Please notice that inside of the parentheses we have a limit with x approaching 1 with sine function in the numerator. And if you are going to realize that if x is approaching 1, my numerator is going to be equal 0, because sine of 0 is equal 0. And if you are going to look at the denominator, you will see that if x will approach 1, denominator is going to also approach 0. That's why I have to use for this part of my problem this theorem. If x is approaching 0, my denominator is going to also approach 0. And if I'm going to look at the numerator, if x is approaching 0, my numerator is going to also approach 0. That's why all this expression is going to approach 1. So what I'm going to do, I'm going to replace the content of my parentheses by 1 according to this theorem. And I have 1 to power negative 1 times limit with x approaching 1, and I have x plus 1. 1 to power negative 1 is simply 1 times, because I have limit of the polynomial, I simply replace every x by the value to which my x is approaching to. That's why I'm going to simply write 1 plus 1. And I have 1 times 1 plus 1 is 2. 1 times 2 is equal to. This is the solution to my problem.